Hi everyone, this week we're going to be looking at the transfer of static electric charges. So I'm sure all of you have had what's happened in this picture here where your hair is statically electrically charged and it's sort of all over the place. So we're going to learn today why this happens. Right, so how do you know when an object is charged? So we have these little objects here on the side called an electroscope. And this has two very thin metal pieces at the bottom called leaves, and they suspend from a metal rod. So you can see on the image on the right, the top there we have the ball or the knob, and then we have a stem with our gold leaves. There are two leaves that hang from that stem, and then it's all encased in a metal case with a glass side wall so you can see what's happening on the inside. So the metal rod is attached to that plate or metal knob at the top. So when a charge is transferred to the knob, so the ball on the top, the charge will spread out over the entire electroscope, and this includes the leaves. So the greater the charge, the greater the separation between these leaves will be. So when we start with a neutral electroscope, these leaves are falling straight down towards the ground, and then when the charge comes onto the electroscope, these leaves will flare outwards. So the bigger the charge, the bigger that flare of those two leaves. And these electroscopes are used to study electric charges. And we call this study of electric charges electrostatics. So in order to predict when a charge is transferred or what charge is transferred into our electroscope, we can use a standard set of charged objects, such as ebonite, so that's a hard rubber, and it's low on our triboelectric series, and therefore it accepts electrons, or we could use a glass rod, which is high on the triboelectric series, and this gives away electrons. So if our ebonite is readily accepting the electrons, that means that it will become negatively charged, and if our glass rod is giving away electrons, that means that it will become positively charged. So who's going to receive the electrons? So let's have a look at our table here on the left, and this is telling us whether our object is going to gain electrons or lose electrons. So let's have a look then at human hair versus amber. So it all depends on which one is higher on our table. So our human hair is right on the top. So third from the top is our human hair. Our amber then is towards the bottom. So what is going to happen is that our human hair is going to lose electrons because it tends to readily lose electrons, and our amber then is going to gain our electrons. And so the electron flow will go from the human hair into the amber. So our human hair becomes positive and our amber becomes negative. So let's then have a look at cotton versus ebonite. So what we would do is we'd take our cotton and rub it on our ebonite rod, and our cotton, because it is higher on the table than our ebonite, will lose electrons and become positively charged, and our ebonite will then gain electrons and become negatively charged. So our electrons are flowing from the cotton to the ebonite. So have a look at plastic wrap. versus cat fur. So pause the video here and do this one for yourselves. Alright, so let's have a look then at the plastic wrap versus cat fur. So plastic wrap is right towards the bottom of the table. Cat fur is much further up the table. So that means then that our plastic wrap is going to gain the electrons and our cat fur is going to lose the electrons. So our electrons are going to flow from the cat fur to the plastic wrap. Our cat fur then becomes positively charged and our plastic wrap becomes negatively charged. So when we're using our electroscopes to detect these charges, if something that is negatively charged is brought towards a neutral electroscope, the electrons in the electroscope are repelled by this negatively charged object. Okay, because we have to remember that only electrons move. Okay, our protons or positive charges never move. It's only our electrons that are moving. So we should remember this from our last unit, chemistry, where as well, only the electrons move. So our electrons in our electroscope are repelled by this negative rod coming towards them. So the electrons move down the electroscope into the leaves of the electroscope then. And now both of our leaves are negatively charged. They're going to repel each other and they're going to flare apart. Now when our negatively rod is taken away, our leaves are no longer repelled. The electrons can move back out of the leaves and up into the stem and knob of the electroscope, and therefore our leaves are going to drop back to their neutral position. So then let's have a look at that in an image. So we have here our neutral electroscope, and what we're going to do is we are going to bring a negatively charged rod towards it. Then what happens is our electrons move out and away as far as possible from that negatively charged rod. And so they can only move as far as the leaves, and this causes the negatively charged leaves to repel away from each other and flare out. And then once you remove that rod, the electroscope is going to go back to its original position, as you can see in image A. So we have two ways that we can charge our electroscopes, or that we can transfer our electrons. So we can transfer or charge by conduction or contact, and we can charge by induction. So we're going to start by looking at charging by contact. So you can charge a neutral object by touching it with something that is charged. So charging by contact occurs when electron transfer from the charged object into the neutral object, or from the neutral object into the charged object, depending if it's positive or negative. So the neutral object is then going to gain the same charge as the charged object that it touched. And this is because our electrons move. So if we're looking here at our image, our first image has a negatively charged rod, and we touch our negatively charged rod to our neutral electroscope. And what happens is that those electrons move into the wings, and the wings are going to flare out. However, if we have a positively charged rod touch our electroscope, all of our electrons are going to move up and into that rod. And what's going to happen is our wings are going to be left with a positive charge, and therefore they're going to flare out because of that positive charge. So they're being repelled because they're both positively charged. So there we go. Our electrons move from the rod into the electroscope, causing it to be negatively charged, and our electrons move out of our electroscope, causing it to be positively charged. Let's then talk about charging by induction. So induction is the movement of electrons within a substance caused by a nearby charge. So there's no direct contact between the substance and the object. So, for example, you rub a balloon against your hair. Electrons will transfer from your hair to the balloon, making the balloon negative. The charges will stay there because we know that rubber is an insulator, so it holds on to a charge. Now what would happen is when we bring our balloon to a neutral wall, the electrons from the balloon repel, and the electrons from the balloon repel the electrons from the wall, leaving a positively charged part of our wall. So as you can see here in our diagram, our electrons are going away from our balloon in the wall. The balloon then induces a charge on the wall because it charges the wall without contacting it. So we haven't stuck the balloon to the wall here. We're just holding it close to the wall. So first of all, we charged it by contact with the hair, and then we charged the wall by induction. So the balloon was charged by contact, the wall has been charged by induction. So when you charge an object by induction, you're using the charged object to create a charge or induce a charge in a neutral object. Then what we do is we're going to ground the charged object so it keeps the charge. So grounding is when you connect a charged object to the ground and you provide a path for charge to travel to or from the ground. So this is what we mean. What we're going to do is we take our charged rod towards our electroscope. So in this case, we have a negatively charged rod going towards our electroscope. What happens is we're not touching it, we're not touching the rod to the electroscope, but all of the electrons in the electroscope are being repelled. So they want to run away. So they all move towards the wings and they cause these little wings to flare out. What then happens is we're going to ground our electroscope. So our electrons are going to flow out of our electroscope now because they want to run as far away as possible from that other negatively charged object. So they're going to go through our ground, which in this case is a hand. And what that then leaves is a positively charged electroscope. So the wings are flaring out and they are positively charged because all of our electrons have left the electroscope. So what happens then if we have a positively charged rod charging by induction? So we bring our positively charged rod close to our electroscope. What happens then is all the electrons are attracted to the positively charged rod. So they move up our electroscope. This leaves our wings positively charged, so they flare out. What we then do is we ground our electroscope. So again, we touch our electroscope with our hand, and this time all of our electrons flow into our electroscope because they're attracted to positively charged things. Okay, so they're flowing into our electroscope. When we take our hand off our electroscope, what we're left with is a higher negatively charged, so more electrons are in our electroscope than protons. So therefore our wings are going to flare out because the electrons are repelling from each other. So once an object is charged, the charges are trapped until they're given a path to escape. So this is called electrical discharge. So when electric charges are transferred very quickly, and this is when we get sparks. So for example, there's a picture of Lightning McQueen here because a lot of cars have grounds because as they're traveling around, they collect a charge. And often, if they aren't grounded properly, sometimes it might happen, especially in older cars, where you'll go to hop out of the car and you'll touch the car and you'll get a big shock. Other things also collect charges. So for example, if you're wearing socks, you're walking across your carpet, and then you go grab the metal doorknob to go to the bathroom or something, for example, you might get a big shock because the charge built up in you from walking across the carpet is now being released into the door handle. Another electrical discharge that you'll know about is lightning. So there is charges built up in the clouds, and they are released down to the earth because the earth or things on the earth are positively charged. So these electrons will jump through the air, create a big spark as they release into the earth. So now let's then look back at our crazy hair. So this happens, for example, if we're taking off a jumper or we've been on the trampoline. So what's happened is that you have created a charge, and this charge has either, for example, electrons have moved up into your hair. They're trying to get as far away as possible, and now all the negatively charged hair pieces are repelling from each other, and therefore it is standing up and flaring out like our little golden leaves.